I have a demo of a switch statement, and I'm sort of pulling in some other things that we've already covered to make the demos a little easier to use. So for example, it's kind of annoying to have to keep running the demo 3, 4, 5 times to show the results of 3 or 4 different paths through it. I've decided to put this loop in here. As long as you enter some positive number, we just follow this brace down. You can see that the last thing that happens in the loop is I'll ask you again for a number, we'll hit the brace bracket, and we'll come back up and do this while again. That way, with a single run, we can test a number of different values. So what's happening inside the while loop? Well, we have this switch statement. We're switching on x, which is an integral type, so that's fine. Here's the non-optional open brace and the non-optional close brace at the end of the switch statement, and everything in between is our switch. And I have a number of different cases. So case 1, that is when x is equal to 1, I'll tell you that you entered 1 and I have a break. Something you'll see quite often is 2 labels right after each other, bang bang. So 2 and 3 are right after each other. This is deliberate, and it means that you want to do the same thing for both 2 and 3. Since we're not doing anything real, all I can say is, well, you must have entered 2 or 3. But imagine a circumstance where you process both canceled and delayed things the same way. So you might have case canceled, colon, and then immediately case delayed, and then all the code to handle delayed and canceled, whatever these are. However, sometimes people do it accidentally, so I've simulated that accidentalism here with 4 and 5. There should be a break at the end of case 4, and there isn't, and I'll show you what happens when the break is missing. And then we have the default. So I'm going to run this through for a whole whack of numbers, obviously. Let's do that now. So if I put in 1, it says you entered 1, that's fine. If I say 2, you entered 2 or 3, and 3 will also say you entered 2 or 3. When I say 4, it says you entered 4, you entered 5. Let's flip back to the code. Because there's no break, it fell through to the 5 case and also executed the case for 5. Probably not what I wanted. We'll try 5, try something else, and finally 0, and we're out. The switch statement certainly takes up a lot less room than many nested else ifs, and it's more efficient than just if testing the same thing over and over again. After all, once we've established that x is 1, there's no way that it's 4. Also, stacking these up like this is more readable than combining them with OR. You haven't seen combining with OR yet, but trust me, this is more readable. So for certain kinds of architecture of your application, the switch statement is really useful. In modern C++, there are some alternatives, especially when you're working with objects and you have hierarchies. You can, rather than switching on something, you can have your objects be of different type and have an implementation of a virtual function in that type handle whatever this is. So you may not see as much switch statements, but when you see them, I want you to be able to read them, and I certainly don't want you writing big, long, nested else ifs when you could have just used a switch.